Hey y'all, so this is going to be a super quick review of exponential functions. So just as a reminder, exponential functions are functions that have a variable in the exponent. So as you can see very clearly, f of x is equal to a times b to the x. So see how that x is up in the exponent, making it an exponential function. And let's just have a recap real quick. A is our initial value. B is our base, or what we multiply by is a good way to think about it. And x, of course, is the variable or what we input each time. Okay, so just quick recap. A is what we start out with. B is what we're multiplying by each time to get our next value. And x is up in the exponent, and it is a variable. That's what makes this an exponential function. Okay, so let's graph the functions f of x equals 3 to the x and h of x equals 1/4, 2 to the x, and just kind of see what they look like. Okay, so pulling up our Desmos calculator. So we want to go ahead and graph f of x is equal to 3 to the x of x is equal to 3. I know usually we do shift 6, but it doesn't work in the star version. So know that if you click on your keyboard down in the bottom left, you can see this a squared and this a to the b. We want a to the b so that we can go and we can put in whatever exponent we want for it. Okay, so that is our graph of f of x is equal to 3 to the x. So notice how it goes right through the value 0, 1. Okay, and it increases as we go left to right. It specifically increases by 3. So if I went to x value of 1, you'll notice that I'm here at 1, 3. If I go to x value 2, I should be up at 2, 9. And so on and so forth. Okay, so let's go back to our little graph. So we have point here, 1, which is our y-intercept, because technically there is a 1 there in front. 2, 3, or sorry, 1, 3, 2, 9, and so on and so forth. Okay, we've talked about this before, but notice how the exponential function flattens out. Okay, it flattens out because it has an asymptote. All exponential functions have asymptotes that guide them. They are horizontal asymptotes, which are just little imaginary lines that guide the bottom of an exponential function. So wherever an exponential function looks like it flattens out horizontally, that is its asymptote. And we always write the asymptote as a y equals equation, whatever value it goes through. So this one would be y equals 0. Okay. So let's look at h of x. H of x is equal to 1/4 times 2 raised to the power of x. Okay. So I'm going to go ahead and turn fx is equal to 3 to the x off. So we get h of x equals, remember to get a fraction, you just do 1 and then divided by. So type your first number, a division sign, and that gives you your fraction. Then I'm going to put parentheses to make sure I multiply it correctly. I want 2, close my parentheses, and then of course I want the exponent, so I'm going to go down here and click a to the b. And that gives me my exponent, and that is where I will put my x. Okay, so notice things a little bit different. So now my y-intercept is 1/4 because my initial value here is 1/4. And then as I keep going, I'm multiplying 1/4 by 2. So 1/4 times 2 would be 1. 1/4 times only 1 would only be 0.5. Okay, so I'm multiplying by 2 each time. So multiply 1/4 by 2 once is 0.5. Twice is 2. 4 times, we're all the way up at 4. And so on and so forth as we go to the right. And then once again, notice how I flatten out right here at the x-axis because I have that asymptote at y equals 0. So asymptote at y equals 0. My y-intercept was 0.25, which is way down here. Then I was at 0.5. Then at 1, 3 times, I'm multiplying again. I'm up at 2. 4 times, I'm up at 4. 5 times, I'm up at 8. And so on and so forth. So notice how because I'm multiplying by 1/4, it's like my exponential function got stretched out just a little bit. Okay. So some key things about exponential functions, their domain and range. Their domain, notice how they go forever in the left and forever in the right. Domain is always going to be all real numbers with exponential function. Their range, though, is always above or below the asymptote. So both of these have an asymptote at y equals 0, and they're above that. So we'd write their range as y is greater than 0. Not greater than or equal to, because we can't be equal to the asymptote, but just greater than 0. Okay, so that is our basic exponential functions. We also have exponential growth and decay, which is the same base function, except instead of b, we have that r there in the middle. So just as a reminder, a is still our initial. R is what we call rate, and they give it to us as a percentage. And we have to convert it into a decimal by dividing by 100. Okay, and then x, of course, is still our variable. So exponential growth is when the common ratio is added or positive. Exponential decay is when the common ratio is subtracted. So with each of these, remember, we look for words that are going to tell us it's growth or decay. And then we have to make sure that we add it if it's growth, our R value, or we subtract it if it's decay. And then, of course, with our R value, they give it to you as a percentage. You have to convert that percentage into a decimal by dividing by 100. Or you can just think about it as moving the decimal place to the left twice. So let's look at example 1. Dinner at your grandfather's favorite restaurant now costs $25.25 and has been increasing steadily at 4% per year. Is this situation growth or decay? So increasing steadily definitely means we are growing in costs. So we would say this is growth. Okay. Our initial $25.25, that's our A, 4%. That is our rate, but we need to convert that rate to a decimal. So we take 4. Move the decimal over, and it becomes 0.04. You can also, of course, always type in your calculator. So you can take 4, divide it by 100, and it'll give you 0.04 as well. So whichever works best for you. Okay. So our initial is 25.25. Our R value is 0.04. So our equation is y is equal to 25.25. Parentheses 1 minus 0.04, and then raised to the x. And we can leave it as that. That is okay. Sometimes, though, on an exam, you might see it simplified. So in your calculator, you can just do that 1 minus 0.04. Which gives us 0.96. So you can simplify it real quick. Or sorry, I don't know why I'm doing minus 1 plus. Because we're growing. So instead of that, we want 1 plus. Sorry, Mr. Darbone's being crazy today. There we go. 1 plus 0.04, which will give us 1.04. And that would be our final answer. Y is equal to 25.25, 1.04 to the x. Okay, one last one. Example 2, your car depreciates 5% every year. You bought it at $20,000. Is this growth or decay? So depreciates 5% every year. Depreciates dk. Okay, they go together. Okay, bought at 20,000, so that's our A. 5%, that is our R. So we would take 5%, move that decimal twice, and get 0.05. Okay, so then as we write our equation, we would write it as 1 minus this time because we are decaying. So y is equal to 20,000, 1 minus 0.05, and then once again up to the x, that x up in the exponent. And if I wanted to, I could go and type that in the calculator real quick to simplify. So 1 minus 0.05 will be 0.95. So we could simplify it as y is equal to 20,000 0.95 raised to the x. All right, y'all, that is exponential functions, exponential growth and decay. Go ahead and complete the review activity.